So there's been a few times where I was working on a scroll compressor, say this was a C-GAM chiller, and the compressor kept having thermal issues and it kept overheating, which was really confusing because I had good suction superheat. Like it was right at about 10 degrees consistently, wasn't having any issues, but I was still having these thermal problems on the compressor. Well, and I say thermal, what I mean is the winding safety kept opening up on the thermal overload. So just taking time to dig and dig and dig, try to figure out what the heck is going on, I finally took the time to take a discharge superheat reading. And sure enough, I was well above 200 degrees of discharge, like line temperature, and my discharge superheat was pushing like 80 degrees, which is not good. So, me personally, if I'm going to deal with a scroll specifically with discharge superheat, on the low end with a light load, I'm okay with about 20 degrees, and that can be up to about 60 degrees. Once I start exceeding 60 degrees of discharge superheat, I know I've got a problem or something is going on. And it may not always be that I've got a high suction superheat. So a high suction superheat can cause an elevated discharge superheat, but it's not the only thing. In this particular cases, I was actually having electrical problems. And even though my suction superheat was right where it needed to be, my electrical issues was causing my discharge side to overheat, which was causing my thermal issues. Now, if you're not familiar, discharge superheat is a very critical number that when we're doing compressor analysis, I really think we should start paying more attention to. And this is true for scrolls, but as you get into bigger compressors, recips, screws, and especially centrifugals, this is a really critical number that we actively use to control the machine. So to get your discharge superheat, you take your discharge line temperature and subtract your discharge saturation temperature from that. The difference in that temperature gives you your discharge superheat value. Now, it is good practice to only be about 6 inches from the outlet of the compressor's discharge port. That's going to give you the most accurate reading. And as you move more into the chiller side and you get more involved in the chiller world and you want to be a quality chiller technician, I highly encourage you to take some time and really look into what kind of discharge superheat parameters you're dealing with versus the kind of compressor you're working on, and start getting your head around what that looks like. This is a very important number, and there's plenty of machines out there that we control the EEV based off of discharge superheat. So if you don't know how to properly use that, especially at a basic level, by the time you get to the more advanced level, it's going to be just one extra thing you're trying to figure out where you can build that practice early on. I'm a big fan of Discharge Superheat. I use it all the time. It is a routine practice for me. If you'd like some additional training, you can go to chilleracademy.com. It's something I built for myself, what I needed when I was getting started in this chiller world. It's there if you need it. With that, MTT, make the time for your family, make the time for your spouse, your kids. I'll see you all around.